Good day, everybody. How are you all? Today, we are going to talk about how to use Excel to do hypothesis test for proportions. So I will share my screen with you. Okay. Says at least 60% of graduate students have assistantships to pay for educations. A college dean thinks this percentage is too high. She randomly selects 50 graduate students and finds that 26 have assistantship. At alpha equal to 0.05, is the dean's assertion correct? Okay, so it should be at least 60% of graduate students have assistantships to pay for education. College thinks that the percentage is too high. Okay, so let's solve the problem. So first we have to calculate a test statistic. Calculate test statistic Z. Okay. Z. Okay. In this problem, sample size is sample size N is equal to sample size N equal to she randomly selects 50 graduate students, and X is your number of successes. Number of successes. Success. And that is equal to 26 out of 50. Out of 50 who have assistantships. Who have assistantships. Assistantships. So number of failures equal to 50 minus 26 is equal to 24. Okay. So both number of successes and number of failures are greater than 10. We need to check that. This will ensure that the sampling distribution of P hat which is sample proportion, is normal. Now, our null hypothesis H sub 0, null hypothesis, this is H sub 0 colon P population proportion is equal to 0.60. Okay. So we can write H sub 0. H sub O is P equal to 0.60 is equal to 0.60. And our alternate hypothesis is H sub 0, I mean H sub A colon P is less than 0.6. Now we will find out whether the evidence from the sample data supports the alternate hypothesis. Okay, so how do I test that out? So I will first calculate, okay, I will calculate sample proportion P hat, and that is equal to X over N, which is 26 over 26 divided by 50. Okay, X over N, and we can do it is equal to 26 over 50 because X is 28 number of successes and total sample size is 50. Okay, so calculate. So the before we do the sampling distribution as a mean of P equal to 0.6, sorry, 0.6, and standard deviation of or standard error or standard deviation of P hat is equal to square root P times square root of P multiplied by 1 minus P divided by N. Okay, square root of P times, so times is this one, okay, times 1 minus P divided by N. Okay, so we are going to calculate that. Square root of, okay, P over N. That should be the parenthesis out there. Okay, right parenthesis. So let's calculate that. And that is equal to, so we do square root SQ equal to SQ RT. Inside the parenthesis, my P is 0.6. Okay. Then I multiply it by 1 minus 0.6. P times 1 minus P. And the whole thing is divided by sample size, which is 50. And we close the parenthesis. And that is equal to 0.06282. Okay, so let's calculate the test statistic. Test statistic is a characteristic of the sample that we have gathered. So we will compare the hypothesized population proportion with the sample proportion and see how far the sample proportion is located away from the hypothesized population proportion of 0.6. So this test statistic formula is P hat minus P, okay, which is the hypothesized population proportion. P hat minus P sub 0. Okay, this null hypothesis P is equal to 0.60. This is our hypothesized population proportion, which is P0. Okay. Okay. So So this formula is test statistic P hat minus P0 divided by, the whole thing is divided by standard error. Okay. So that will be equal to where is my P hat? My P hat is in cell E12. Okay. So actually it's E13. So let me put a parenthesis in front of E13 minus, okay, minus P0 is 0.6. Okay. That's my hypothesized population proportion. And that has to be divided by standard error, which is in cell H13. No, not H. It is H15 actually, H15, which is this one. So that's my test statistic. And now we need to find out. So this is a left tilt test because the alternate hypothesis is less than. So this is a left tilt test. Why? Because the alternate hypothesis have two slanted lines meeting at an edge pointing to the left. So this is a left tail test. So left tail test. Okay. So let us find out the area cumulative, find out the cumulative area to the left of Z equal to minus 1.1547. Okay. And for that, we will use, so this area to the left of Z is called area to the left of statistic is also a statistic, or the cumulative area, I should say. Let us find out the cumulative area to the cumulative area to the left of this cumulative area is also cumulative area is also called p-value, which is the probability of finding a test statistic more extreme than what we have calculated. More extreme than what we have calculated. More negative, that means, than what we have calculated. So how do I find the area to the left of minus 1.1547? Okay. Or what we have calculated. That is more negative than minus 1.1547. So for that, cumulative area we will use equal to, okay, equal to normal NOR, normal S standard distribution. Okay, normal S distribution. S means standard, which is the Z distribution. Okay, and my Z is minus 1.1547, and I want the cumulative area. So for cumulative, I say true. And that cumulative area, okay, cumulative area is 0.02. This is equal to the p value. So how did I do? Is equal to norm NO norm equal to norm dot S dot dist, and then my z value is dot dist, and my z value is minus 1.1547, and then I comma true. That means yes, I want the 1.15147, and then I said true. That means yes, I want the cumulative value. Okay, so if we move, okay, so if we can move, okay, so cumulative area is also called p value. Okay, and cumulative area, here's all this, we don't need that. So cumulative area is the p value. Okay, so if I click on this, okay, so the cumulative area or the p value, okay, so cumulative area is same as the p value, also called same as p value, and that is the formula that I am going to use, norm.s dist minus 1.1547 comma true is p value. Now compare this p value, compare p equal to 0.124, 3 places of decimal is good, with alpha equal to 0.05. Remember, alpha is the maximum probability of probability of making a type 1 error. I'll write the whole thing, probability of rejecting H0 when it is true. That is, we should not have rejected H0 when it is true. Rejecting H0 when it is true. It is also called type 1 error. Type 1 error. Now we compare P with alpha. Okay. So alpha is the, let me correct it, is maximum probability, MUM. Maximum probability of rejecting H0 when it is true, type 1 error. Now P is greater than alpha. P is greater than alpha. So decision is do not reject H0. What does it mean? It means there is a high probability that the test statistic can have a value as high as minus 1.1547. So we have assumed the null hypothesis is true, and now we have calculated a test statistic that is a characteristic of the sample, how far away it is located away from the mean, which has yielded a z value with a high probability. That means, yes, the null hypothesis, what we have assumed, should not be rejected because that value of P is possible. Okay. Decision is do not reject H0, and the main reason is the P value, that is the probability of getting a test statistic as extreme as minus 1.154 or more extreme is very high, assuming H0 is true. So P is greater than alpha, therefore do not reject H0 is the decision. I'm coming back next time to show you how to do this problem with another option, with another way. Same problem, another way. Okay. So here basically we calculated a test statistic. First, we checked out that the that the number of success, which is 26, is greater than 10, and number of failures is 24, is also greater than 10. Then we can assume that the sampling distribution of p hat sample proportion is normal. So null hypothesis is p equal to 0.6, and the alternate hypothesis is p less than 0.6. Okay, because that's what the dean thinks. Okay, so it produced a test statistic with a probability value very high, greater than level of significance. Remember, alpha is a level of significance, is the maximum probability of making a type 1 error. P-value is greater than alpha. Decision failed to reject 80. Also, we can write that, let me go, at alpha, conclusion is at alpha equal to 0.05. There is not enough evidence to support HA, because we are failing to reject the null hypothesis at alpha equal to 0.05. Okay, so if you like this video, please share with your friends. And if you like this video, please give me a thumbs up. I really appreciate that. Please do not miss me next time when I'm coming back to show how this problem can be done in another way. Okay, same results we can come, same conclusion by doing the problem in another way. So don't miss it by any means. And if you like this video, please give me thumbs up. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Thanks for watching. Take care. Have a nice day.